Question number 3 is another Poisson distribution question. Usually there can be two Poisson distribution question, and usually if we have two Poisson distribution question, at the end there would be a hypothesis testing question that deals with Poisson distribution question. So if you look over here, the first one, A, is find the probability. Then second, again something to do with probability, but here question number C, it's about hypothesis testing. So it's hypothesis testing. So keep that in mind when you do this question. So let's start with question number A. So we have this information given. An online shop sells a computer game at an average rate of 1 per day. This per day is the unit. This rate of 1, this rate of 1 is the mean. So that means this is the lambda. Lambda equals to 1. So the unit is per day. And the event, as you know, the context of the event is an online shop sells a computer game. Remember this context. That is very, very important. An online shop sells a computer game. So what we have to do now is, first of all, define it. So event, number of event. What is the event? An online shop sells a computer game. So it means number of computer games sold. The context is not complete. Sold by an online shop. It's still not complete. We have to write per day. So that's what it is. So the definition would be Poisson distribution lambda 1. Now let's read the question. Find the probability that the shop sells in 7-day period. Remember that. So the next thing we have to remember is more than 10. So in a 7-day period, this is the unit. And the next thing we have to remember is this one. Sells more than 10. Sells more than 10 is the random variable. Remember, shop sells, that's the random variable. So we have to remember that. So what we have to do, we have to change this all over again. So this is number of computer games. We correct it over here. Sold on online shop per 7 days. So it is going to be y Poisson. 1 times 7 is 7. Now we could have done this directly, but I recommend that you do step by step and change the random variable, because that would give you a clear idea what was the original value. So we have to find the probability sells more than 10 games. Remember, number of games is the random variable. It means probability of y is greater than 10. So that means, think about this, it is discrete random variable. So more than 10 means 11 or more. So since the table given at the back of the book, what we have is cumulative, mean it has to be less than or equal to. So this is 10, 9, 8 and on. We have to write 1 minus probability of y is less than or equal to 10. So when we subtract from 1, that is 100%, less than or equal to 10, we will get what they originally asked for, more than 10. So let's look up the table. So we have lambda equals to 7. So let's scroll down and we have lambda equals to 7 and we are looking for 10. So here and here, be very careful with the block. So this is going to be less than or equals to 10, 0.9015. So this is going to be 1 minus 0.9015, and what we get is 1 minus 0.9015, and we have 0.0985. 0.0985. Now question number B. Now pay attention because this is quite irregular. So what we have is once every 7 days, The shop has games delivered before it opens. Find the least number of games. We know that number of games is random variables. They're talking about least number of games. Now pay attention to number of games. So they're talking something about a random variable, but they're not talking about finding the random variable. They're talking about finding the least number of random variables. So what do they mean by that? Let's continue. The shop should have in stock. Okay, every shop should have something in stock. They should never have less than that, but they should have more than that. Suppose if you have every day 5 customers coming to the shop, they should have at least 5 items in that shop and more, because what if more customers come to the shop? So this is something you have to remember. So we have to have the probability, that amount of random variable or more. So this is what they mean. So in stock immediately after a delivery, so that the probability of running out of games, so you don't want to run out, you want to have that amount. So if you don't have that amount, you would be running out. You would be running out of that before the next delivery. So the probability is, now they're talking about probability. So the probability is less than 0.05. Okay, so this is quite interesting. So let's write this down. So we have 7 days. So we have basically the same distribution. So I don't have to define it. I'm going to write y Poisson 7. Okay, next, we don't want to run out of something. So let there be a number of games, computer games. So they have to have at least a number of games or more. At least means greater than or equal to, otherwise they will run out. So the probability that they would not run out, meaning the probability of y is greater than or equal to a, that probability is usually equal to some value, but this time it is less than some value. So that probability itself is less than 0.05. Now that's a bit strange. Probability and inequality. But let us continue. So what we have to do is, first of all, make it cumulative. Otherwise we cannot look up the table. So for making it cumulative, it has to be 1 minus probability of y is less than or equal to a minus 1. Now what does that mean? Well, think about this. If it was something like this, suppose probability of y is greater than or equals to 5, then if I write 1 minus probability of y is less than or equal to, it has to be 4 because of cumulative. Because to be greater than or equals to 5, it means 4 is here, it has to be 1 minus probability of y is less than or equals to 4. So 1 less. Similarly, to be greater than or equals to a, it means 1 minus, it would be 1 less. For that reason, I'm writing a minus 1. So let's simplify this. That would be minus probability of y is less than or equals to a minus 1. And that would be 0.05. This 1 would go to the other side. So 0.05 minus 1. And that would be minus probability of y is less than or equals to a minus 1, and this would be minus 0.95. If we cancel this the negative sign, it would be y is less than or equals to a minus 1 greater than 0.95. So that's what we have. Now what we have to do, we have to look up the probability, and we have to find the random variable. Remember, this is the opposite. We know the probability, we have to look up the probability, and we have to find the random variable, but it cannot be 0.95. It has to be a little bit greater than 0.95. So let's look it up. So this is the value of lambda. Lambda has to be 7, and we are looking for a little bit greater than 0.95. So we have 0.9, 0.94. So greater than 0.95 has to be this one. This is greater than 0.95. and the random variable would be 12. So we got it. So what we have over here is therefore probability of y is less than or equals to 12. Whatever that is, it would be greater than 0.95, and we know what that value is. So that means a minus 1 is equals to 12. Therefore, a equals to 13. So we found the least number of games they should have. They should have at least 13 games or more. The final question is hypothesis testing. So let's read this very carefully. It is a very good idea to always read the question. In an attempt to increase the sales, they want to increase the sales of the computer games. The price is reduced for 6 months. Okay, since price has never been mentioned before, it would not be part of the parameter of the questions. So the price is reduced. Okay, so in order to increase the sales, they reduce the price. This is what they do. So this is what they do. A random sample of 28 days. Remember, first it was per day, that was X. Then the question was 7 days, and now yet again we have to change the random variable. 28 days is taken from this 6 months. This 6 months does not really have any effect on the sum. In the sample of 28 days, 36 games are sold. 36 games are sold. Remember, this is the random variable. We know that the number of games sold is the random variable. So this 36 number is our random variable. This 28 days is our per unit. And what they're saying, it increases the sale. As you know what happens in hypothesis testing, we have a null hypothesis, so which would be lambda equals to original value unchanged 1, and the alternate hypothesis. So what they're saying, they're going to increase the sales. If they're increasing the sales, it has to be more than 1. So that's how we start the sum. And remember, step 2 has to be defining the distribution, which would be redefining in terms of per 28 days. And then we do the sum, which would be 36 computers. If you combine the two, equal to and greater than, it would be greater than or equal to 36 computers, and we find the probability and check whether it is significant or not. However, they did mention suitable approximation. That means our distribution might not work. When will the distribution not work? If the Poisson has a lambda more than 10, the distribution would not work. We just did that in the previous sum, and then we have to use normal approximation. So let's start. So step 1 is defining the distribution. So H naught, or null hypothesis, is lambda equals to 1. H1, alternate hypothesis, is greater than 1. Let's define the distribution. So we have written x and y. So what we have to write here, let's write A. So that would be number of computer games sold by the online shop. So online shop per 28 days. That means the Poisson distribution would be 1 into 28. And the probability, remember the random variable is 36. That means combined equal to and greater than. It would be A is greater than or equals to 36. Now if you look up the table, you will know it's not in the table. So we have to use the approximation. So using normal approximation, normal distribution as an approximation. So what we need is mean, which would be the same as lambda, and variance, that would also be the same as lambda. So we can use the letter C. B cannot be used because of binomial distribution. We have 21 and 21. Now we have to do continuity correction. Since it is already equal to, so we can do continuity correction like this. So it would be 35.5. So we can write probability of C is greater than 35.5. We don't have to write the equal to sign anymore because it's continuous. So the next step, so for standard normal distribution 0, 1. So what we have, therefore, probability of Z is greater than 35.5 minus the mean is 28 divided by sigma is square root of 28, and it turns out to be So 35.5 minus 28 divided by square root of 28, and it turns out to be 1.417. So 1.42. So in order to make this less than, we have to write 1 minus z is less than 1.42. Now remember, it doesn't really matter what value it is because it is continuous. It doesn't really matter because it's not discrete. So let's look up the table. So let's look up the standard normal distribution. We need 1.42. So let's scroll down and we have 1.42 over here. It's 0.9222. So this would be 0.9222, and if we subtract from 1, we get 1 minus 0.9222, and that's 0.0778. So now let's check the significant level. So the significant level is 5%, that is 0.05. So we can write, since 0.0778 is greater than 0.05, it is not significant. It is not significant. So that means we accept H naught. One way of writing accept H naught is fail to reject. It's a good idea to use the word reject. Either you reject H naught or fail to reject H naught. So instead of writing accept H naught, I'm writing fail to reject H naught. Now we have to give the conclusion in context. So the conclusion was, in order to increase the sales of the computer, the price has been reduced. Hence, there is evidence that the reduction in price did not increase the sales of the computer games.